Voice not audible. Okay. All right. Not audible. Can you check once in your phone? Check in your phone. It is audible. All right, guys. So the class, whatever way we are going to do today, let's start. In the last class, I told you molality. Today, one more concentration term we are going to study, which is going to be mole fraction. Mole fraction. We represent it by X. Mole fraction will be represented by X. Okay. What is a fraction? Fraction means number by total number of particles. Number by total number of particles. In this case, it will be number of moles of a particle by total number of moles inside a solution. Video is not clear, they are saying. कट के आ रहा है ना. Okay. So mole fraction, which is represented by X, it is number of moles of a component by total number of moles. Number of moles of a component upon total number of moles present in solution. Okay. So by this our formula becomes mole fraction of solute equal to moles of solute by moles of solute plus moles of solvent, which is the total number of moles in the system. So this is the formula. Call it as equation 1 for the day. Call it as equation 1 for the day. It's okay, whatever way the audio is fine only, video will remain like this today. There is some problem, okay. So you have to bear with it. By next class it should be fine, okay. By next class it will be corrected. But because my voice is coming to you and video is also coming to you, although it is little bit stuttery and laggy, but you can manage, okay, for one class. From next class it should be fine only. They'll arrange new wires and something. There is some problem in a wire or HDMI cable, but it should be fine by the next class. So mole fraction is moles by total moles. Same way, mole fraction of solvent also we can find. Mole fraction of solvent will be moles of solvent by total number of moles. And always remember, the sum of mole fraction is always 1. When I add the two together, sum of fractions is always 1. So when I do x2 plus x1, you are going to get 1. If I add them, the denominator is n1 plus n2 and numerator will also become n1 plus n2. So n1 plus n2 by n1 plus n2 will become 1. So sum of mole fractions is 1. And because you can see mole fraction is independent of the volume of solution, that means it is independent of temperature as well. So mole fraction is temperature independent. Temperature independent. Temperature independent. Okay, so this is the one. Now let us solve some problems from the mole fraction. One more formula that I want you to learn. Even if you don't learn that formula, you can do the question by unitary method. But one formula that I want you to learn is you can convert mole fraction to molality. You can convert mole fraction to molality just by simple formula. So you can remember this formula, you can learn this interconversion formula, which is molality versus mole fraction. First learn it, okay, then we can prove also from where this formula is coming from. So the formula of molality in terms of mole fraction is molality equal to x2 by x1 1000 by m1. x2 by x1 1000 by m1. Please remember it. You can derive it also, there is no problem. You can easily derive it. But this is one formula that you can remember. Molality equal to x2 by x1 1000 by m1. m1 is the molar mass of solvent beta. Here m1 is the molar mass of solvent, not the solute. Molar mass of solvent. Mostly you will be taking it as 18 gram only because water will be the general solvent. Okay, so these are the formulas that you can remember. I've given you 4 formulas. Please learn them and then let us start with our question. So question number 1 goes like this. All of you need to answer it. Okay, all of you need to answer it. Question is, all of you need to answer it. Question is, 8 grams of NaOH is dissolved in 8 gram of NaOH is dissolved in 9 grams water. 8 grams NaOH dissolved in 9, instead of 9, just take it as 8 gram NaOH dissolved in, keep quiet everybody, dissolved in 27 grams water. Find mole fraction. Find mole fraction of NaOH. Find the mole fraction of NaOH. Okay, you can find it out quickly. Better screen looks clear only to me. For the first class, you bear like this. Next class, it will be better. 8 grams of NaOH. So I can find the moles of solute. 8 grams by molar mass of NaOH 40 gram. So I have got 0.2 mole NaOH. 0.2 mole NaOH. And then moles of water, which is 27 grams by 18 gram. Molar mass of water is 18 gram, which exactly goes 1.5 times. So 1.5 mole of water. 1.5 moles of water. Yes, correct. So 2 by 17 is correct. 0.117 what you are saying is correct. So we get mole fraction of NaOH is going to be moles of NaOH by total moles. Moles of NaOH is 0.2. Moles of water is 1.5. Moles of NaOH is 0.2. So answer is 2 by 17. 2 by 17. Correct. 0.117. 0.117 is the mole fraction. Same way, there is another concentration term, we call it as mole percentage. Whenever you multiply fraction with 100, that becomes mole percent. Okay. Another concentration term is mole percentage. that is mole fraction into 100. So if they ask you by what mole percent NaOH is present, so mole percentage of NaOH in this case is 0.117 into 100, which is 11.7%. Okay, just like there is weight by weight percent, there is another percent called as mole percent. So mole percent is 11.7%, mole fraction is 0.117. Okay, let's go for the next one. All of you can tell me. What mass of CH3COOH must be dissolved? What mass of CH3COOH must be dissolved in 780 grams of benzene? Okay, benzene is another solvent, it is C6H6 the formula. What mass of acetic acid must be dissolved in 780 grams of benzene such that mole fraction of benzene is 0.6. Mole fraction of benzene is 0.6. Okay, this is the question. You can try it and tell me the answer, what you are getting. Bhuvan, I know that I am lagging. It's not in my hand, beta. Right? I am not the one who controls all the wires and computer and stuff. So there is a little bit lag, I know. You have to bear with it. Okay? Every time things cannot be perfect for you. During your preparation, there will be many days where you will face a lot of difficulties. Okay? So be ready for all of them. So can you tell me the answer for this one? I'll solve it for you. You can just see here. So what mass of acetic acid? W2 they are asking. W2 they are asking. Weight of acetic acid they are asking. Dissolved in 780 grams of benzene. So W1 is given 780 gram. Beta, molar mass of benzene is 78. You can check. 6 times 12, 72. 72 plus 6, 78. That means moles of solvent is given 780 over 78, which is 10 moles. There is 10 mole benzene. What else is given? Mole fraction of benzene is given. That means X1 is given. Solvent ka mole fraction is 0.6. Okay. From here I can also say solvent ka mole fraction X2. Mole fraction of solvent, or I can directly use it from the solvent only. So solvent mole fraction can also be written as N1 by N1 plus N2. N1 by N1 plus N2. So we can just mention it here. Mole fraction of benzene, which is 0.6, is moles of benzene, which is 10, by moles of benzene, which is 10, plus moles of acetic acid. I'll just keep it as N2 only. I'll just keep it as N2 only. From here, I get 6 plus 0.6 N2 equal to 10, and 0.6 N2 is equal to 4. So number of moles of acetic acid comes out to be 4 by 6 and 40 by 6, 40 by 6, which is 6.67 moles. 6.67 moles. So I have got N2. We know N2 equal to W2 by M2. Moles of solute equal to weight of solute by molar mass, and the molar mass of acetic acid is 60 gram. 60 gram. So I can say 6.67 equal to W2 by 60. So W2 comes out to be 60 times 6.6, which is 400 grams. 400 grams. Good, that is the answer. 400 gram is the correct answer. Correct, last year, correct. That is correct. Let's go for the next one now. Next one is this. Can you solve it, everybody? Go for this. Tell me an aqueous H2SO4 solution. An aqueous H2SO4 solution is an aqueous H2SO4 solution is 39.2% by weight. Calculate mole fraction of H2SO4. Calculate mole fraction of H2SO4. Those who are studying with me for last 12 days and you are enjoying the classes, you can just hit a like for me. You can hit the like for the video. Okay. Bring water now. (39.2% by weight), calculate the mole fraction of H2SO4. Calculate the mole fraction of H2SO4. .10 some of you are getting. Let me check. So meaning of 39.2% by weight is, if I take us 100 gram of solution, if I take 100 gram solution, out of the 100 gram almost 40 gram will be H2SO4, means 39.2 gram will be H2SO4, rest will be water, means 100 minus 39, 61 gram will be water. 61 gram will be water. That is the solution for us. So we can say here moles of H2SO4 is 39.2 by molar mass 98 gram. Okay, which is exactly going at 0.4, 40 by 100, which is 0.4, and moles of water from here will be 61 gram water by 18. 61 by 18. Okay, so this is exactly going at 0.4 moles, and this is going how many times? You can see here it is going 1 by 3, because 6 by 18, 1 by 3, it is almost 1 by 3. So 10 by 3, which is 3.33 moles. 3.33 moles. So we get mole fraction of H2SO4, which comes out to be moles of H2SO4 by total moles, 0.4 plus 3.33. So answer is 0.4 by 3.73. Okay, which is 4 by 37, 0.10, that is correct. Okay, this is the answer. 4 by 37.3. You can solve it, it will come out to be 0.106. This is the mole fraction. Next question we'll do where mole fraction will be converted to molality. So let's do this one. Question number 4. Question is, an aqueous glucose solution is 2 mole per kg, means 2 molal, is 2 molal, find mole fraction of glucose. You can do this question just by basic definition. Or you can use the formula I told you. The basic definition will be like this. 2 mole per kg means 2 mole glucose in 1 kg water. So what is given to us here is moles of glucose are given 2 moles and weight of water is given 1000 gram. If you know the weight of water, then you can know the moles of water. So we get moles of water are 1000 by 18. You can learn this value, it is 55.55. So you know the moles of water, you know the moles of solute, you can find the mole fraction of solute, which is going to be moles of solute by total moles, which comes out to be 2 over 57.5. 2 by 57.5. Mole fraction question, generally they give you answers in fraction only. So they'll give you answer like this. It is 20 over 57.5 or 575. 20 over 575. Or on the table of 5 you can cut it and say the answer is 4 over 115. 4 by 115. 4 by 115, this is the answer. So many times mole fraction answers are just given as it is just given as a fraction only. So they'll give you in a fractional form. 4 by 115. The other way to do this question was by formula. One interconversion formula in the beginning of the class I have given you today, which was molality equal to mole fraction of solute by mole fraction of solvent into 1000 by molar mass of solvent. x2 by x1, 1000 by m1. Molality is 2, x2 is x2, x1 can be written as 1 minus x2 into 1000 by molar mass of water, which is 80. Same thing will happen here, again it will become 55.55. So you can see here same formula is going to become. So I get this term goes up, 2 minus 2x2 equal to 55.55 x2. 2x2 goes there, become 57.5 x2 equal to 2. So x2 is 2 over 57.5, which is again same 4 by 115. So you can do the question just by, by the formula or just from the definition itself. Then we have another concentration term that we can call it PPM and PPB. Parts per million and parts per billion. Parts per million, parts per billion. Parts per million means if I take 1 million gram of solution, in that how many grams of solute will be present? So mass of solute present in 1 million, 1 million means 10 ki power 6, 10 ki power 6 grams of solution. 10 to the power 6 gram of solution. This is ppm. So when you want to find the value of ppm, it will be W2 by W. W2 by W into 100 was percentage. So percentage means out of 100. Here instead of multiplying by 100, you multiply by 10 to the power 6. Multiply by 10 to the power 6. Okay. And ppb you multiply by 10 to the power 9. So ppb means weight of solute in 1 billion gram of solution. So W2 by W into 10 to the power 9. 10 to the power 9 is billion, 10 to the power 6 is million. Okay. So mass of solute present in 10 to the power 9 gram of solution. Okay, so question can be asked like this. Question can be asked like this. An aqueous solution of calcium fluoride is 0.0084% by mass. Find ppm. That could be a question. Find ppm or find ppb also could be a question. It's like this. Aqueous NaCl is 20 ppb. Find mass of NaCl present in 20 liter of solution having density equal to 1 gram per ml. Okay, you can solve these two. Get me, tell me the answer, then I will tell you what the answer is. You can solve this. Okay, so I'll be solving it. First one, 84, Ranga is saying 0.0084% means if weight of solute is 0.0084 gram, then solution is 100 gram. Solution is 100 gram. That is the meaning. This much grams dissolved in 100 gram of solution. So ppm comes out to be weight of solute, which is, I can call it as 84 into 10 to the power minus 4 by 100 into 10 power 6. Okay, this double zero goes 10 ki power 4, 10 power 4, 10 power minus 4 will become 1. So I am getting 84 ppm. 84 ppm. What about the next one? Bharati correct, Raju correct, Sriram correct. Good, 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 good. Do the next one now. 20 liter of solution you have taken, which is 20 ppb. Find the mass of NaCl. Okay, I'll solve this one. You can see here. Solution is 20 liter, its density is 1. That means density equal to mass by volume. 20 liter in milliliter will be 20,000. So weight of solution comes out to be 20,000 grams. 20,000 grams. Weight of solute they are asking. PPB is given. So formula of PPB is 20 ppb means weight of solute by weight of solution 20,000 into 10 to the power 9. 10 to the power 9. So from here W2 comes out to be, so this 0 goes 10 to the power 8, these 4's 10 to the power 4. So we get W2 as 4 into 10 to the power minus 4 gram, which is 0.0004 grams. This is weight of NaCl present. They could have asked you moles of NaCl present. You can just divide it by molar mass afterwards to get the moles as well. So yes, that is correct. Good, Shanmukh. Okay guys, then thank you. Bye-bye. That is all for today's class. I'll see you all in the Monday's class. Bye-bye.